What is the correlation coefficient for linear associations? What is R? Well, this is printed a little bit differently than it is expressed in the textbook that I'm currently teaching from, but is saying exactly the same thing. In the textbook I'm teaching from, it has all of this over here, all over n-1, so that we're seeing fractions inside of fractions. It's turned that division by n-1 into multiplication by its reciprocal. So this is really saying the same thing. As is noted on this website, it is Wikipedia, but is factually correct in this case. First of all, we're seeing that we would need, for our ordered pairs, we would need the mean and standard deviation of all of the x's and the mean and standard deviation of all of the y's. It notes down here something that I had noticed, that score minus mean over standard deviation looks like z-scores. So we are standardizing the x's and we're standardizing the y's. If you had to calculate this by hand, what you would do next, keeping the pairing of xi comma yi together, then for each pair, we would do these calculations and multiply within the pair. After you've done that for all pairs, add them all up and then divide everything by n-1, which is the same as multiplying by 1 over the quantity n-1. Well, besides the fact that this looks like standardized z-scores, what else does this look like? If all of those y's were the same as x, think about, in each ordered pair, each y is the same as x, like 1, 1, 2, 2, 3, 3, and so on. Then this portion here will be the same as this portion here. When you multiply something by itself, you're squaring. That should be reminiscent of the formula for standard deviation. Standard deviation is a measurement of dispersion or spread. That is the same thing here. Although things kind of work in the opposite direction of what we are going to expect, the absolute value of R cannot be bigger than 1. And the closer that absolute value is to 1, the closer the scatter plot will be to a, quote, perfect line. When the correlation coefficient R is negative, we will see a scatter diagram that has a general trend of decreasing, as if the line has a negative slope. And if the correlation coefficient R is positive, we would see a general trend of increasing as we look left to right, which would go along with a positive slope for the, quote, perfect line that would be getting closest to the points in our scatter plot. Now, there's one piece of information that needs to be added to this regarding the claim that the correlation coefficient R is a unitless number. Suppose the scores X have been measured in feet and the scores Y have been measured in gallons. Then when you compute the means, X bar would be in feet, Y bar would be in gallons, the standard deviation of the X's would be in feet, the standard deviation of Y's would be in gallons. And so each of these standardized scores here, for the X's, you'd have feet minus feet over something in feet. So feet over feet, the feet units would cancel out. Similarly, gallons minus gallons would be in gallons, but the standard deviation of the Y's is in gallons, so the gallons unit would cancel out. There is no unit to the number of ordered pairs, so we wind up with something that is unitless when we talk about R, the correlation coefficient.